everyone. I welcome you all to another episode of Web Mentors webinar series. Today we have our special guest Subhaditya with us. Subhaditya is a machine learning enthusiast and a technical content writer. He is currently experimenting in the fields of astronomy and biology with deep learning. So, welcome Subhaditya. We are super excited to have you here today. So, stage is all yours.
Okay, thank you for the great introduction. Yeah, awesome to meet everyone who's here. So I will be sharing my screen.
Yeah.
Yeah. Okay. I am assuming it's visible. My screen's visible, right?
Yeah, it's visible.
Okay, perfect. So I'm just going to keep the screen on while I tell you what's going to happen today. So as the poster and everything mentioned, today will be on data science, and it'll be more of an introductory session. It's just 1 hour, so obviously I can't provide every technical detail off the bat. But what I will do is I will tell people how to start, more of why to start, why would we care about data science, and to an extent, as a bonus, I will also be showing you a small demo of a machine learning code with the same thing which we're doing with data science. So today, my flow will be this. And what do you get if you stay awake through this hour? Let me show you. Firstly, this meme is not fully accurate per se. If it is, you should read the little footnote. I will zoom in a bit just in case. Okay. Okay. So here's a little footnote. If you know, and you've probably seen pretty much a huge number of people being excited about data science. So why? Firstly, because it's a hype, the new trend, however you want to put it. But that's just a secondary thing. So it's a hype for a reason. Why is it a hype? That's the whole point of my talk. Okay, so just as an explanation for this meme, if you haven't thought about it, a lot of things which I will be showing you today was a separate job at some point, and then it became redundant because of data science. That doesn't mean that it's going to take over every job. That's not happening because every time it takes over one job, another one is created. So right now you even have, I think, 10, 15 types of data scientists at least. Again, those are beyond the scope of this discussion. So maybe if you want, you can search for that. Okay, so let's move ahead. What do you learn at the end of this 1 hour? What do you take back? So firstly, you get to know how I made this cool little tiny graph, whatever, how I am getting the screen. So obviously it's not PowerPoint. If you have been coding, if you have looked at courses or YouTube or something, you will see this kind of screen very often. So I have code and I have my output. So this is called a Jupyter notebook. Just background. So I will tell you how to get all of this thing running in short, because again, I don't really have enough time to give the whole discussion. But again, I will send this notebook over. There'll be a link at the end, I think, where I'll tell you where to get this notebook. Okay, so today we'll be talking about what is data. So as a data scientist or anyone who's interested in data, what kind of things will you be working with, and where will you get them? Where do you get all the data sets, all that? I will also be talking about why we care, right? And in fact, I had thought that instead of telling you off the bat why we care about data, I will show you a demo. So this whole session is going to be interactive, but since it would be better to have the questions at the end, so please ask any question you feel is relevant, and I will attempt to answer all of them towards the end. Okay, I will also be showing you a lot of code, and I'm pretty sure it might look very foreign and alien to a lot of you, and that's okay. That's totally okay. Again, you will have the notebook, you will have this document at the end, so don't attempt to memorize anything. In fact, if you're a note taker, that's cool. If you're not, well, that's totally cool because you'll be having this whole thing. And any part you don't understand, try, instead of looking at the code, try and understand the principle behind it because that's more important. Later, when you look at code or when you look at this notebook itself, you will be able to understand it. Or in fact, even if you're doing a course or you have this in university or you're just looking at a book, it'll be easier for you to understand if you know what I'm talking about. So finally, as I mentioned, the bonus is that we'll be taking everything which I will show you today, and we will pop that into a machine learning model per se. More explanations towards the end because that's a bonus. Okay, so where do we start? This is a question which I get from a lot of people. So much about data science. You can do this, you can do that. Again, I'll even tell you some of the cool things you can do with it. But where do you start? So if you're just starting out, welcome to the club. It's an awesome club to be a part of. The communities are amazing. If you're watching this webinar, you're already part of one. So that's awesome. Um, and the first thing I feel you should do is listen to this webinar since you're here. The second thing is do a course. Okay, that doesn't mean that's all you do. In fact, I will show you a course. Okay, so it's Udemy. Okay. So this is one course which I find is extremely popular. It does say machine learning, and I will tell you why. But this is a really great place to start. Again, I will paste this here just in case you want to look at it when you get this document later. Okay, so once you have done a course, you will find that I've covered a lot of things by the time I'm done with this that are the start of an idea. So my objective by the end of this hour is that anyone who is looking at this will have an entry level idea into all the bits that go into making a data science pipeline, or basically finding any problem and solving it by using the techniques of data science. So, as the poster mentioned, the talk was about really understanding your data. So, before we can get to really understanding our data, well, what's data? There's a million definitions, but what data do we have? So, there's some here on the screen. Firstly, memes. All of this, all of these are also data. But today we will not be focusing on this because these are image data. And data science, mostly in terms of business and everything, it focuses on tabular data. So anything like an Excel file, say, just as an example, and any kind of database file, any files generated by stocks, sale data. So, for example, you're selling a product and you have customer information across the whole year or 2 years maybe, and you also have the price, how it goes up, goes down based on the market, everything. So this is one example. This is one very real life example which is worked upon, and it's one of the most important things when you're going for a job or an internship or whatever, to be able to pick up this data in any form that's given to you and identify the purpose of it and do something with it, right? That's the whole point of this field. And now you might notice that sometimes I'm oversimplifying concepts. That's on purpose because, again, this is not meant to be an extremely difficult to understand talk. If you have any questions which you feel that are a little beyond the scope but are still related to data science, still feel free to ask them. I will try and answer them towards the end. Okay, what's this weird line thing you're seeing? Now, this is just a bunch of random points I'm plotting. So I've taken random numbers from 1 to 100 and I've just plotted them. Why? Just to show you that this also counts as data, right? Now, if you look at this picture, it might look vaguely familiar. That's because this resembles, okay, I'm not saying it's even mathematically close, but excuse me, it resembles the output you get from electronic device in the hospital, right? You might have seen something like this for the heart rate monitor, etc. So what you can do with this is that the same thing, it also applies to wearable devices. If you've heard of the Apple Watch or the smartwatch or whatever, all of these things actually end up generating these similar, okay, not the same, obviously, because it's a bunch of random points, but similar um, data points. And you can take this and actually pop this and do an analysis on it. So if assuming this was mathematically correct definition of your heartbeat, I can take this data and I can actually find out when you are having an anxiety attack, let's say, or when you are stressed or when you're happy. And this is actually being done. I can say it might not strictly come under any of your courses, but it's data and you can still consider it as a part of data science. Okay. One more thing I wanted to clarify before we actually got on to anything else is that there's a huge comparison between machine learning and data science. I feel people get really confused because you see the same things popping up, and that's totally cool. If you see someone talking about regression and everything in both places, that's because many of these share the same fundamentals, right? So anything I'm teaching you today, I'll be showing you, discussing today, translates completely into machine learning. That doesn't mean that that's all you need for machine learning, and it doesn't go vice versa either. Machine learning is a really broad spectrum, and there's different subfields like deep learning, etc., which involve a completely different variety of topics that data science cannot handle. So it goes uh, beyond its capabilities. Okay, but that doesn't mean that data science is not useful. It is, but the whole point is that it is meant for something else entirely, and machine learning is works on different types of data. So, as an example, um, data science would work on tabular data. For example, this particular graph here. But if you want to recognize the types of cars, say, just by means of a picture, that would go a bit beyond the capabilities of data science. And then you might look towards machine learning. Again, if you want a little more information, you can ask me in the questions, or I will be adding a bunch of links in this document as well, so you can go through that later. Okay, so this is what your life is going to be if you go into data science or not. So everything you see here centers upon data, and I feel like it's a very accurate picture because everything you have starts from here. It starts from there, and you build up. As you will see, as I go along, everything builds up from here. What are these things around? Pandas, NumPy, Matplotlib, sklearn, PyTorch. So these are all libraries, and what they do is that they help you do specific things. So I will actually be using everything on the screen except PyTorch because that's for machine learning. And I've kept this here on purpose just to show you the difference. So I will explain what all of these do. And the cool part is they're really easy to use. If you look at courses, I feel I've done quite a few of them, and I feel like they make it look very complicated. There's just so much information to take in at once. So when you look at it, it feels overwhelming, and that's understandable. Right? You are expected to be overwhelmed because if you're not really learning anything out of your comfort zone. But by the end of this, you will actually know how to start using everything here except PyTorch. Again, if you want to learn more about PyTorch, you can contact me later, but that's beyond the scope of this discussion. Okay, so what can you do once you know something in data science? And this doesn't mean that you're an expert in it already. So what can you do, say, after maybe 2 months or even 2 weeks, actually? This doesn't mean that you just need 2 weeks. It just means that you can attempt these problems, which you can't do without this information. So first thing is get a job. Uh, Obviously, it's the hype now, and if you have seen reports, which I didn't want to link, but it pays a lot more compared to other fields in some places, right? This again doesn't mean that this is the only thing you need. It's just a part. And why it pays more? That's because it is an extremely important field for any company, because it allows you to take all the information that the company is generating. So, for example, you take Flipkart, they have a lot of sales. And if you're just selling without looking at what's being sold, who's buying it, everything, that's cool. You're still going to get money. That's fine. But if you look at, say, you look at one particular state and you see that, okay, these guys are buying this specific thing more. So you stock that place a store with more of that product. Now this comes under data science, and this is why it's so important today, because it allows you to take in everything that you are already doing and get double, triple, or even 10 times the benefit from it. So these links here I will show you again. The second thing is save lives. Okay, so there's this one website called Omdena. Their website takes a little time to load. But anyway, they have, as an estimate, 26 projects. They're over 84 countries. What do they do? So these guys, they tie up with NGOs, and every time there is some form of disaster, like this particular thing here, disaster response. Again, I won't try to load their website. It takes a little time. They have a lot of pictures. But what they do is that they take data from governments, they take data from organizations, and they only work towards things which would help society. So a while back, I found a problem called Pump It Up. I don't want to search for the link again. If you want, I will post it. But it was a competition where they took a survey and they took data of all wells and pipeline systems in a place in Africa. And they wanted, um, the challenge was to identify which pipe would fail without knowing. So from before, just by looking at the data, the challenge was to identify which pipe would fail. And the cool thing is, it's possible, and people won that challenge. People managed to find out which pipe would break before it happened, and they managed to go there and provide more resources to those places. And that's just one example. So you see this screen here. This is from a site called Kaggle. I will just show it to you. Kaggle, if you are going into data science or machine learning or even deep learning, to be honest, it's your home away from home, your best bet. And this is where you get all the data. Not all, but it's a really great place to start. So anyone who's looking at it, I would really advise you to check out Kaggle. I've put a link in the notebook. But what are these? These are competitions, right? So I've taken a screenshot of the completed ones and just some of them. And you see this really huge value here. These are all in dollars. And what these are is these are the prizes if you come first. So it's like a competition. And the competition is to do the best, get the best model, do the best data science on this. And if you win it, it's really hard. Okay, but I personally know people who have won these challenges. I've spoken to them. I have interacted with them. There are some of them who are also third year, fourth year students. So it's not impossible. It's just hard. And money aside, just look at the scope of the challenges. Think you can change the future of flight, or passenger screening algorithm. All of these are extremely important challenges, which I wouldn't say weren't possible to be solved before, but they are easier to do now because of data science. And the cool thing is that if you uh, look at whatever I tell you today, it's the start of being able to do any of these challenges. And if you can understand everything you see now, which won't come instantly, and that's okay. You are expected to look at it multiple times. You are expected to try and run or go out and learn something else. You can actually participate in these. In fact, I would advise you to participate in this anyway, even if you feel like you don't know anything, because that's how you learn. And I will be showing you more about Kaggle later. But yeah, that's one thing. So this link here will be for further reading. This is also, it's a data science blog and piece of code analysis I've written. It's also in the same format as a Jupyter notebook. This data was also from Kaggle, and look at it later, because if I show you now, it will probably go above your heads. But once I'm done with this, it'll be way easier to understand. Okay, so let's go and do a deep dive per se into data science. So this is Pokemon, and yes, I chose a Pokemon dataset because that was my childhood, and why not, right? Why a Pokemon dataset? Because A, it's not serious, and B, just to show you what you can do with a simple dataset and how much information you can extract from it. So let me show you the data. Right? This is also on Kaggle, as I was showing you, and it's there wasn't really a competition with this. It's just somebody found 721 Pokemon and they uploaded uh, all data about it. So this is the data. I will show you properly in the notebook, but again, I'm showing you this to show you what Kaggle looks like. If you can see, there's usability, which means how good the data is, because this data is really clean. It's nicely formatted. There's nothing wrong with it. Uh, and it's just really easy to use. And it's an awesome place to start. But mostly it won't be like that. And the whole point is to be able to handle anything that's thrown at you. Okay. The second thing you see here is this. This is what your data looks like. These graphs and all you can ignore because those are generated. That's not part of the data. This is the data, whatever I'm highlighting right now. There's 13 columns, and these are just stats, right? And off the bat, it seems like, okay, fine. They're just numbers. You can't really, I don't know, it doesn't look like there's a lot you can understand just by looking at it. And that's why data science comes into the picture. Okay. So how do you get this data? You just sign in, which you have to. I have signed it on another browser, so it's not going to work here. And then you can download it. And you will get this as a CSV file. CSV. What's that? Simply put, it's just data like this. So say I have 10, comma, 12, comma, 13. That's all. It's comma separated values. And your whole file is just like this, say, with different numbers, obviously. Yeah. How do you get this? Remember this picture which I showed you? So we take the first thing. We take Pandas. And what is Pandas? It's just a Python library. If you see, I've imported pretty much everything. There's a new thing here, which I will explain later. Okay, so every code you see right now is in Python, and anything you don't understand, it's totally cool. Try not to look at the code. Obviously, I had to use the code to generate everything, but if you don't understand the code, just try and understand what I'm talking about, because the code is just a representation, and it's not that this is the only way of doing it. It's just one way of doing it. And once you do a course, look at more people's work, etc., you'll be able to understand this really easily. Okay, so first, we need to take the data, and this is the first step of the pipeline. If you try and see an overview of everything that's going to come after this, it's a pipeline, and it'll be stepwise. First thing, you load data. So how do you load data? You identify what data it is. So this is CSV. It's a comma separated value. If you don't have a CSV, look at this. These are all the options you have. Some of these are just absurd and obscure, and you might probably never have to deal with them. And I'll be really happy for you if you don't. But if you do, this library makes it really easy to just read anything. You can read a CSV, you can read an Excel file. In fact, you can even read a text file. You can copy a table from somewhere, and you can directly get it in this format. If you see, and if you've seen Excel before, which you probably have, you get something like this. And this is called a data frame. Names aren't really important, but I'm telling you the name because the codes after this use the word data frame. So hopefully it won't be a complete shock if you look at data frame. All I'm doing here is that I'm taking the first 10 rows. Python starts from 0. So anyway, first 10 rows. And this is everything that came here. If you notice, it's the same thing, minus the graphs. First starts with purpose graphs with the. Now, this is our data. What do we want to do with this? That is the question. And that is what you should be asking yourself before you get into anything. That is the first step of the pipeline, right after you read the data. Actually, even before you read the data. What do you want to do with it? In our case today, for this demo, I will be attempting to find out as much of the information as I can in very simple lines. So it won't be something extremely complicated. But the whole point is to take this small little piece of information and take out everything you can from it. And along the way, I'll be covering a lot of terminology, which might seem unfamiliar, and that's cool. I will also tell you where you can get information about these. So in a Jupyter notebook, anything you write, you can just click Shift and Tab, and you get this little thing. All this does is that it gives you the Python documentation for it, and you can view the whole thing. It'll tell you what it does, how to do it, the syntax. There's even examples. And this works for pretty much every Python library, just as a bonus. If you didn't know about it, it's Shift Tab. And this thing works on any platform, so that's it. Why is this important? This will save you a lot of Googles. If you know drop, okay, what is this? Again, I will probably not explain everything line by line, but I will tell you what it does. So if you see this data set, there's this one weird hash symbol here. And this came as a side effect of the data itself. And that's cool. But we don't want it because it's pointless. It's just telling us what number it is. We remove it. So we drop it, basically. And this is a really important thing to know in Python or in data science or whatever. If you know the term for it, you can probably code it, at least from the library. Okay, so shape will give us the shape of the data. So right now we know we have 800 rows and 12 columns. These are the columns. I have removed this hash, so otherwise it would be 30. Now we have our data. How about an initial look? And these are things you would actually do when you look at any data. So it's a start, and it's an initial pipeline which you will follow. You kind of have to, because it comes as part of understanding what the data does. This is a very simple metric. It tells you how many values you have for every column. So every numerical column. If you notice, there's no name, type 1, type 2 here, because there's no numbers there. You can't count. You can't find an average of text unless you convert it into a number, which will come later. So now you have a count, you have a mean, you have the standard deviation, and some statistics, minimum value, maximum value, all this. These come in handy again when you know what you want. Right now, this is just a bunch of numbers. Again, just like the data, it means nothing. So what do we want? The first thing which I want to do is I want to find out if there's any values here which are missing, which means when someone was entering the data or when you were getting the data, that particular thing wasn't there. Why do we care about that? It's because you can't sum nothing. You can't perform maths on nothing. So we remove it or we change it. How do we find that? Again, just arbitrary code. This little snippet allows me to find out every column and how many nothings there are. So if you see type 2 has the most number of nothings, 386. This is a very clean data set, so it's easy enough. And we have 800 rows, and 386 of them seem to be empty. We really, that means that this column doesn't matter, and it will probably end up messing our data. What do we do with that? We remove this. I haven't done that um, because I wasn't even trying to modify this data much. But how do we remove it? So if you think about it, we can't just remove the whole row. We can't do that because that would mean that I'll directly lose 386 rows out of 800, which is a lot of data. Instead, what we can do is we can replace it. So say, for example, we have NaN means nothing in Python. We can replace NaN with poison, which is weird because this Pokemon does not have poison. But what else can you do? Or what you can do, and what in this case, because there's 386 out of 800, is that you remove this whole column. You don't use it. Because if you use it, it's worse to use this than not having this data point. And that's okay. And this step is called feature engineering. Many people requested me for this as well. So feature engineering, technical term, but the whole point is to have an initial look at your data and identify the flaws in your data. This data set doesn't have many flaws, but if it did, your job would be to identify the nothings, identify which value comes out of nowhere. So if you have, say, I don't know, data set with 1, 2, 3, 4, 5 or something, and suddenly there's 500, and there's also 10,000 arbitrary data, but this means that there could be something wrong. Again, there's no must. There could. And your job is to identify these things, because if this was age, if this was an age data, I don't think we have people who are 10,000 years old. At least I hope not. But yeah, you would see that these are values which probably shouldn't be there. It could be 50. Someone just added an extra zero. This thing was probably 10, or good cases 100. Someone mistyped, or there was some corruption, and that's cool. Or maybe it's a robot. I don't know. So that's it. That's one step which you should consider. Again, I'm not covering every type of data feature engineering because that's not possible. There's a lot. And at the end, I will link you to places where you can go and look at everything that exists. You don't need to know all of them, but just in case you want to dig deeper and learn more. Now that we've gotten rid of the missing data, or at least I've decided to not use this column at all. So let's just look at the unique values. What does that mean? That means that right now we are actually getting into the science, data science of it. And we're looking at the data in ways beyond the table and beyond what you can. If I just look at the data set, I won't really be able to identify much. See, this is a small subset. If I take the whole data, there's 800 rows. Pandas doesn't show me everything at once, but what do you get out of this? You don't. You can look at it, and that's about it. It's not going to give you much information there. Okay. Now, to find out how many unique values there are, there's a little syntax, and this is part of the Pandas library. Again, if the syntax looks weird to you, that's fine. That's totally cool. Just try and understand what we're doing. So for every column right now, we're taking all the data from that column, and we're taking out the number of unique values. For example, if we take name, if you notice, these have become numbers, and I will tell you why that is later. If you take name, there will obviously be different names for every Pokemon, right? But if you take numbers, types, types like grass, fire, whatever, these are common. And if you look at the unique values, you see the most, and it's 800 because there are 800 different Pokemon here. But there seem to be just 18 different types or 19 type 2. Um, these are just numerical values. And if you notice, it seems easy to say that many of these values coincide. You can say that the maximum value or the maximum number of unique values of name over here is 800. The maximum number of unique types is 18. And this, you already have a much better idea of your data. This is just a toy example, but this applies to company data as well. You can find out the number of unique customers, the number of different jobs they're doing, occupation, etc. Okay. Now for something cool. Who is the strongest? And you might feel that it should be easy enough to do just by looking at it, but of there's a lot of information out here. And funnily enough, it actually is easy. It's one line of code, just this one line of code. Again, syntax might look weird, but let's break it down. And this is, I feel, the most important thing to know when you're doing data science or even coding, in fact. What do you want to do? We need to identify the one which has, say, the greatest attack, the largest attack. And to do that, the first thing is to identify the largest attack, right? So we're taking the max or the maximum of the attack, and that seems to be 190. Once we have that, then we can go through our whole data and just say, okay, fine, find out which has the attack which is equal to the maximum attack. In fact, if you want, you can add random numbers here. So say we can say it's less than the maximum attack minus 30 or something. 40, right? And you see a lot of them pop up here. And this literally took barely any work. We just had to change a few characters here and there, and you suddenly have a way of interacting with your data. And right now we know that the strongest person was 449, which makes absolutely no sense to me. Why did this happen? Is because you can't work with text, right? So what I did towards the end somewhere is that I converted the text to numbers. And you would need to do that, but for the purpose of our example, yeah, I just reset the data set. And right now the strongest person seems to be this mega mu2 x. Okay, I didn't know that existed. If you notice, we still have the same data, but it's a 163rd row, and there's 800 rows. And if you're just looking at the data, you won't really be able to find this out on your own, especially considering that this is a small data set. I have personally worked with data sets over 10 million rows, 50 million rows. There's literally no way you can even look at it and get anything out of 50 million rows. I don't know, unless you're a robot or something. Okay, so let's make this a little more complex. And the whole point of this part is to show you how easy it is to do things. What if, instead of just taking one parameter, like attack, say, what if I wanted to consider the rest of them, defense, speed, special attack, whatever, and even the total, because why not? And what if I wanted to say that I want one parameter which takes into account all of this, but not directly. So I don't want to just sum them up because there's already a parameter which does that, total, which sums up all of these things and gives you one aggregate. What if I wanted to have a column which takes, say, I don't know, 20% of attack, 20% of HP, 70% of attack, and all that? You might think that it looks complicated now. Now things are starting to become a little harder to do, but they're actually not if you understand or if you look at what we're doing. Firstly, let's go one by one. And this is not, again, this is a very general approach, but if you see, I'm showing some of the basic concepts. Now this can go to do extremely complicated things, or you can go the other way around and do extremely simple things. But this falls somewhere in between. So we break it down. we break down what we want to do. Firstly, let's just find a sum. So let's find a sum of all the attacks, all the HPs. And this is the total amount of HP over the whole thing. Why am I doing this? To show you the syntax. Dot sum. Okay. Now, uh, since I changed it, yeah. Now what we do is we take out just these parameters. We don't care about the types right now. We don't care about the generation or if they're legendary. So all we do is that we extract these. And if you see, this looks like list syntax if you work with Python. If not, that's totally cool. All we're doing is taking out specific columns from the dataset. Once we do that, we can do something really simple. We can have a list of all these. This is just to make it easier, because why would you really write down the names of all these columns by hand? Once you have the list, you can take the first element and the second element. So basically, we're taking HP and we're taking attack. And I can literally write plus here. So I'm taking this whole column. And what it's doing is that for every row, it's taking this particular column and it's adding it with the corresponding values. So in this case, it would add 106 plus 190 for everything. And it will give me one value. Now this is cool because you can literally add any operation here. You can do a minus if you want. Minus means nothing here. If you want, you can even do a multiply. And you see, you're not really changing a lot, but it's doing a lot of things which would be a headache to do elsewhere. Even if you're on Excel. I know you can script Excel, but I feel this is way easier to do. And if it's easier to do, that means that you have time to do a lot more. And you can do many, many things with it. Okay, so let's make a list of what percentage we want something. Again, I'm saying that this might look complicated, and it's meant to, because if I show you everything easy, then you might have a little misconception about the difficulty in this, but it's not impossible. And if you break down everything into small bits, you can see what we're doing. So for example, I've kept this really huge line here on purpose. I've kept it just because it looks complicated. And it is, because there's a lot of things going on here. But what are we doing? So our objective right now is to take each of these values. So for the first column, I just want 0.2 of that column, which means that if I have this attack here, say 49, then I don't want 49. I want 0.2 into 49. Plus, I'm saying 0.8. So I want 0.8 into 49 again here. And likewise, I want my values to go across. So I want 0.2 of the first, 0.8 of the second, 0.4 of the third, etc. So all we're doing is we're making that into a list. And we're just going over the list. That's all that this part is doing. We're going over the list, and for every column, we're identifying the respective percentage or whatever you want from it, and we're multiplying it. So if you see, we've actually covered all this before. The same syntax here is the same syntax here, except with a multiplication sign. The x is just values from the number of elements here. So 0 till the length of this. That's all we're doing. And it's done. Okay, what's this weird .t thing here? So let me show you what happens if I remove this, because I feel that would make it easy to understand. You have this really huge thing, and if you see, it's not going vertically, it's going like this. Why is that? Because what this is doing, because I'm not using anything related to pandas, which you can. So for example, I can skip the .t step, I can skip a bunch of steps if I used pandas functions directly, but I didn't want to. Just to show you that this thing, everything over here on this line is just basic Python syntax. There's nothing extremely insane about it. This particular thing is called list comprehension. This is just a multiplication, and this is a for loop. That's all. And you can take all of this and you can put this into a data science pipeline without really knowing anything extra. Okay, now that we have this horizontally, which I don't want, what do? I need to flip it, right? Again, if you want to sit in code, this flipping part of it, that's totally cool. That's up to you. If you want to do it as an exercise, sure, why not? But you don't really need to, because all you can do is take the transpose of it. It's just called transpose, mathematical term for converting all rows to columns, vice versa. So all I do is I put a dot and I put T for transpose, and we're done. And that's literally all we need. Oops. Okay. And we have what we need, right? We have uh, all of these values, if you see, have changed. So the first one, pretty sure was not 9, it was 49 or something. But it's just taken a small fraction of it. And it's done that for everything. And we did that in one line. Okay. Now, what were we trying to do? We were trying to find the strongest Pokemon with this additional constraint. So what do? We save this to a data frame. Again, same thing as this. And we take the exact same code as before. So this exact same code. But in this case, we just change the name because we're using a different variable for this data. And that's all. And you get this. And if you see, it's still the 163rd Pokemon, which we don't know who that is, right? So how do you find that out? Again, if I had taken the names into account, it would have been easier. But this is a demo to show you just the sheer amount of things you can do with it. Once we find this, we can find out which one has the strongest attacks, 152, whatever. And what if we wanted to make a new total? So the previous total was for their values. It was just a sum over all the columns. Now we want to make our own total because we've changed the values. And it's really simple. All you have to do is dot sum, which, if you remember, I showed you a little while back. What's this axis? This means that don't sum horizontally, um, sum vertically. That's all. So axis 0 and axis 1. I just again kept it here because these are like little things which, if you look at codes on Kaggle or if you look at courses, it might seem a little odd um, and a little weird because no one really explains these things very well. So it's just there. Okay. Now we take this database, this data set, whatever, our modified version of it, and because if you see here, it's just these values, right? We don't know who 163 is. I can find out, and that's exactly what I'm doing. Except right now I'm using Pandas syntax. Same thing again, completely same thing. But instead of finding the strongest attack, we're trying to find, this whole thing breaks down to, we're trying to find the row with the maximum total value here, which came from our modified data set. So everything we did on the 0.2%, blah, blah, blah. We found the totals of it, and we're trying to find the Pokemon with the maximum value of that. And again, it seems to be immutable. Wow. Okay. Now for the next bit. Let's fight. Because Pokemon battle, I mean, you have to, right? Let's take everything we have learned so far and build a little extra functionality. If you have played Pokemon, which I really hope you have, if you haven't, I know you might not be a gamer, but check it out. It's fun. At least it was fun when I played. Okay, so what we're doing right now is that if you see, there were these type things here. And if you haven't heard of Pokemon, which I will be surprised, but okay, just in case you haven't heard of Pokemon, each Pokemon has a type. And when you are playing the game, or if you want to make them fight, obviously, if they have types vastly different from each other, it would be harder for you to win. So, for example, you have, I don't know, an electric Pokemon, and then you have somebody with water. You are probably going to get electrocuted. Same thing. Okay. Again, it might sound silly to someone who's played Pokemon before, but bear with me. So what do? This part is not in the, it's not in the data right now. There's nothing in my data here just looking at it which says that, okay, if I, take Bulbasaur, which Pokemon in my whole 720 or 800 Pokemons will win against Bulbasaur. There isn't. I mean, if you play the game, you can probably find out, but again, it would be really hard for you to do. But Pandas, it's extremely easy. Okay. Combining everything we've talked about right now. Okay. I'm just going to scroll to this bit. Yeah. So right now what we're doing is we make a table. There are more elaborate versions of this, but purpose of a toy example. Let's say that the first column here is the type. So for example, you have a Pokemon with this specific type. And the second, oops, this was our random thing. Okay. And the second column here, so one, is basically the type which can defeat. So if you have grass, fire is stronger. If you These are from the website, so but it's obvious if you have fire, and water would be able to put your. Okay. Now what we want to do is we're going to take a random Pokemon. Okay. It's going to take Flareon, just another Pokemon, whatever, and we are going to find out which Pokemon, if I have, can defeat it out of everything, my whole data set. I can do this easily and in probably one huge step, but just breaking things down. All we're doing is that in this thing is that we're taking the Pokemon, going through the data and finding out which type it is based on its name. Once we have that, we can take this, pop this into this, and compare it and see which type can defeat it. And that's all. That's pretty much it. We already have these Pokemon. So Flareon is a fire type. So all we're doing is we're trying to find out all of the Pokemons here which are opposite. And if you notice, we are using 3 or 4 data sets here. And the syntax is pretty much the same thing. We've been doing this all along. And this is why it's so easy to work with data. And this is why you can get arbitrary complexity. You can get things which you might not consider directly. Now, all this comes with practice. I have been at this for a while, and even I have a really long way to go. But the point is, you can do it. And if you even look at this notebook twice, you will be able to do a lot more once you understand all this. Okay, so who won? Again, simple. All we do is we take this data set. So this one here, whatever we've just created, of the ones which we feel can defeat this Pokemon based on the type. And then we do the same thing. We try to find the maximum total value. So this total is a sum of all these parameters. And same syntax again. And we see that this friend of ours okay, can defeat our Pokemon and can literally defeat it the best among everything. Okay, toy data set. But where does this come into help for real life data? Let's take the same Flipkart example. We have a lot of products which we are selling, right? And we find that, again, as I was talking before, a specific community buys one product the most. Okay, that's cool. But what if we wanted to find something which would work very well in that community? So say there's one community, school starting, everyone's just buying bags all of a sudden. And then you see that in some other community, people are buying bags and they're also buying pencils. So what you do is that you look at the community who is just buying bags and you recommend them pencils. Now this is called a recommender system, and it probably is a lot different because it involves a lot of things, but it starts from here. And it's such a really important and cool thing, which can be done by everything you just did right now. And this obviously isn't the whole breadth of things you can do. In this, I know it's been like 45 minutes. There's so much you have already done. And you can see how amazing it is and why it's so trusted and hyped. Because all of a sudden, you can take everything that's already there, because all this data is being generated anyway. And you can just find out so much information from it, which will make your business, say if you have one, better. Or if you're trying to sell a product, you can identify who's going to buy it, etc. Or you can perform analysis on this, on any kind of data, and that's why it's cool. Okay, so before I wrap up, let's show you the bonus. The bonus is machine learning, and the whole point is till now we've just been working on manually doing things with the data, right? Now, what if I want to identify if given, say all these numbers, say I have the types, I have the HPA type, blah blah blah, and I also have a generation, because why not? I want to identify if this Pokemon is a legendary or not. And note that I'm not telling I'm taking a data set which doesn't have legendary in it. So I would give it information where, let's assume we take a random Pokemon. So if I just give it a bunch of values, okay, and I want it to identify if it's a legendary or not, then I don't know. How are we going to do it? This is something which is a machine learning problem. Again, one more reason, if you see sklearn here, it was there in the meme long time back. um, this is another package, right? And one thing to note is that these packages wrap over a lot of code, a lot of math and everything. And if you are interested in machine learning or data science or whatever, it's awesome to use the package. But if you want to actually understand it better, you really need to know how it works. So I can just use this library directly and it'll do a lot of things for me. And that's cool. But if a time ever comes where it doesn't work, there's no way for you to know why it didn't work if you don't know what it does and why it does what it does. So arbitrarily, I won't really be explaining this a lot. So what we're doing is that we're taking data, we're taking this whole table, and we're setting aside parts of it. So there's one part of it where I am removing this legendary column. Why am I doing it? To see how well I've done, right? So there's one part of the data which my model doesn't know. It's it's a test set, and the other one, I'm telling my model that okay, I'm trying to predict legendaries. So what do? Firstly, this little bit of code here converts all these names into numbers. And right now, if I show data again, after I've done this, because I haven't done this, notice they all became numbers. And right now, if they're all numbers, except the legendary, because again, I'm not taking that into account now. Because they're all numbers right now, I can pop them directly into my model, right? And if you notice, that's it. Like this is these three cells are code which you need to understand, which you need to do machine learning. Okay, why is it so hyped if it's just this much code? Because this identifying this, what to use, what parameters to use. So let me show you. This particular random forest is just one of the most popular ones. It has so many parameters, so many of them. And unless you know what this does, you really can't identify what's probably causing a bad score. This is a very nice, very good to work with data set when you're starting out. So off the bat, you get a 96.2% accuracy, which means that out of my whole data set, if I give it extra data, there's a huge, there's a 96.2% probability that it'll be able to identify if it's a legendary without actually even knowing anything about it. Now, what I left out, and again, left out on purpose, are these. I've taken the name, right? I've not removed the name column, if you see here. But is the name really an important factor in choosing a legendary? Probably not, right? Probably not. And these are things which you should take into account. These are the important things, which you can't do without understanding your data, which is where everything which we talked about right now comes into play. So this is the first step. And everything I told you right now is just the start of it. There's a lot more you can do with just this information. Um, okay. But the cool thing is that once you've done all that, you can directly pop it into something like this and get information which you wouldn't be able to do. Like if you give me, I don't know, six numbers, it makes no sense to me how it's even related to legendary. But it does. It does mathematically. And the whole point of machine learning as an extension to data science, but not being data science, right? It's an extension. It's extra things you can do over your data. And this particular thing goes to extreme complexity. There's a lot of stuff that's involved before and after you do it. But these are three lines which show you the power of machine learning and what you can do right now. You can pick up any data set and you can apply all this. And technically, this is also part of data science because this value, again, it means nothing to me. What does mean something to me is an ability to identify who did better. Okay, so that's pretty much it from my side. These are just some classifiers. What are you supposed to do right now? Again, once you have this notebook, there's a lot of links, so just go through them. And for now, questions. I'm
Thank you
just
so
gonna.
much. That was really helpful.
Thank you. Okay.
So we
Do we
have
have
like,
questions?
yeah, lots of questions. So I am going to bring them
Okay.
like one after another.
Okay. Cool. I'll stop sharing my screen. Actually, no. I'll keep it on just in case.
Yeah,
Okay. How can we choose a classifier
last
based
one.
on training set size? Um, so training set size is not a parameter for choosing a classifier. Okay. Training set size would not, again, it's not a parameter. What the parameter is the data, right? You can have 10 rows or you can have 20 million rows. It might not make much of a difference, but of course, if you have linear data, so for example, if you have 1 2 3 4, okay, it'll give you a straight line, say. In that case, you would need a linear classifier. Now this doesn't matter if you have 50 million rows. If your data is linear, you would still need a linear classifier. So training set size doesn't really matter. It might in one particular specific domain is when you have a really huge data and your system isn't good enough to perform a very complex model. But again, that's arbitrary. There are ways to get over it. So,
So let me bring the another one.
uh-huh.
Which one is better for data
SQL.
science, SQL or Pandas?
Okay, so to be honest, these two are different things. You can do some amount of database work with SQL. But the cool thing is you can literally take an SQL data frame and put it into Pandas, which just instead of from CSV, it's from SQL. You can even give it a link and it'll allow you to work with your database. SQL is a language for querying the data set. It's not for data science. You can get some functionality from it, but you can't really do stuff like regressions and everything on it. And if you could, hats off to you. Congratulations, you have accomplished something amazing with your life. But I mean, why? Uh, and the cool thing is with Pandas, another little lesser known fact is that every SQL query can be executed on a Pandas data frame. So you can use both if you want. Why? I don't know, but just in case.
Okay, so we have next question here.
Okay.
What is difference between data science and data mining? So we had another question. What is the difference between data science and data analytics? So you can cover both the questions in like say one
Okay.
time.
Okay. Cool. So many of these things are similar, right? But the whole point is they share a different perspective. Data science, data analytics, and data mining are technically part of data science. Data science is the umbrella on top of it, and there's subcategories of it. Data mining is taking huge amounts of data from data warehouse. Like say for example, Google generates, I don't know, billions of megabytes of data every day, as a really dumb estimate, but whatever. So data mining would be to go through all the data and getting something out of it. um, Data analytics would be taking whatever you got out of it and applying it to a business perspective. And that's the important difference. Many of these things share similar things. So pretty much anything you do with data mining, you can also say, fine, but it's also data analytics. It is, but when you do it and for what you do it, that's the main difference between all of this. And data science is just, it includes everything.
Okay, so we have next question here. How to get
Okay.
started to Kaggle? Do you recommend starting on a few courses online?
Okay, yeah, I do. There's a link in the notebook as well with a bunch of courses you can start with. To get started on Kaggle, firstly, again, as I said, do the course, right? And then come back to this document if you can, or any other document, and see how much you understand. If not, and I feel like this is why I kept my screen on. But let's go to Kaggle,
Wait,
just as a
I'm just
demo.
adding
Okay.
it to screen. Yeah, here
Ah,
you
yeah,
go.
please do that. Okay, perfect. So, how to get started with Kaggle? Firstly, go to Kaggle and look at compete. Right, there's one tab here, competitions. And I would say look at completed ones when you're starting out. So let's just take the first one here. It says Titanic, and I guess everyone starts with that. So if you look at it, and why I'm showing you my screen in the first place, is that there's something called notebooks here. And what this is that it's people who have participated in it showing their work. And this is the best part about Kaggle because you get to see how people do on this challenge. Might take a little time to load. Okay, I'm not even sure if it's loading. That's yeah, okay, perfect. If you see, this is also the same thing which you were looking at here. It's also Jupyter Notebook, but it's Kaggle's own notebook. And this is the first thing you should do. You should go to Kaggle, even if you don't know anything. Just go to Kaggle and look at people's work. See how they approach stuff. See how much you understand. That's all. And once you do that, while you're still doing the course, you can participate and you can hopefully do better than they have. That's pretty much it. I guess you can stop screen sharing now.
Uh, I hope that was
Okay.
helpful enough. So we have next question. What are the various steps involved in an analytics project?
Okay. So pretty much everything I've covered so far, except one part which I didn't cover because again, it's not really possible to fit everything in this duration, and that's the production pipeline. What that means is that right now, if you saw the end, I had like two models. Say, sometimes that might not be the best thing for the job. Sometimes you might need multiple models for the job to combine and give you one thing. So after all this, you have two options. If it's a project which will work for the users, you deploy it. So for example, the Flipkart recommendation system. Right? That's also a product of an analytics project, but it's being used. So that's deployment, and there's a whole lot of drama involved there. That's one part. And another side is that if you're showing analytics, so for example, everything I showed you right now, it's just showing. I'm not really doing anything with it. I'm trying to identify some specific parameters. And to do that, there's something called dashboarding. So basically, all the graphs, all the figures, nice values, whatever, you pop them into one page. People will hate me for this, but that's pretty much all a dashboard is. A bunch of analysis on one page or multiple pages. So you can explain. And that's about it. There are other steps which are part of data cleaning, but again, that comes later. You don't always need it. Yeah. I hope that answers the question.
Yeah. So the next question we have here is: are multiple of domains in data science like finance, retail, healthcare, etc. So which domain will you recommend and why?
Um, this is a little hard to answer because it's not a general thing. There's not
Yeah.
one domain which is better, obviously. But I would recommend firstly see what you like, okay, and see what you can stick to. So, for example, I know if I go to a chemistry domain, I might probably not like it for very long because I'm not that fond of it. But healthcare is something I like. And again, it doesn't mean that you just decide what you like and jump into the wagon or whatever. Sometimes there are things to consider, like right now, every domain which is mentioned here, finance, retail, healthcare, whatever, these are the places where data science is being used the most, right? So it doesn't really matter which one you go into as long as you feel like you can stick with it for a while. So if you want to go into finance, but you really don't even, I don't know, care about looking at lots of dollars everywhere, probably not. Right? That doesn't mean you can't do it. So that's the cool thing again. You can start with finance, and then everything you've learned in finance translates to retail. I can't say the same for healthcare, but you can still use parts of the thing. So choose what you feel like you can stick with, because it's going to be there for a while.
Okay, cool. That was really a great answer. So we have next question here. Is knowledge of ML, DL, and AI required to start working job hunting as a data scientist?
Short answer, no. Long answer depends on where you're looking and what type of company. Because again, it would depend, right? If you say that you're a data scientist and someone asks you linear regression, you don't know what linear regression is, you should probably not apply for that post. Again, look at the requirements of the job. So if they're saying that they're working with big data, you might probably need ML. DL, no. DL is a different thing altogether. It's again good to have. It's awesome to have actually, but it's a different portfolio. You might probably not even have to work with tabular data at some point. AI, yeah, I don't know. It seems to be a really huge misconception, but AI isn't really a proper job domain. It's a term, right? And somehow people use everything for AI when it's not. So if you say AI, that's a combination of machine learning, deep learning, and something called reinforcement learning. And you don't need to know any of that for data science. So probably not. Those are all different jobs. But if you do know them, good for you. Congrats.
Okay, so we have few more questions left. Let's take this one. What
Okay.
other career opportunities exist in data science apart from data science scientists or data analysts?
Um, well, that's a hard thing to do because you've generalized a lot of the domains. But what exists in data science, if you consider things apart from data scientists or analysts, is that you can look at the other aspects of the pipeline, right? So, for example, I need to build a product. So I need to build Flipkart. Let's just say I don't know why I'm going with Flipkart, but let's just say we're taking Flipkart. Okay, so Flipkart is a data science project, but there's a lot of stuff involved in it. You need to build the app. You need someone to work with the servers. You need someone to make it look better than a 1940s HTML page. Uh, you need someone to maintain the pipeline. So all of these are also data science jobs. You might not have to do this work, but you still be working with the data. So you might have the job of optimizing, getting the data and storing it onto the Flipkart database. That's it. That's also a job. And if you know machine learning, if you want to learn machine learning, that opens up a lot of things there as well, which are connected to data science as well.
Okay, that was helpful enough, I guess. So we have like very interesting question here. How you
Mhm.
started with machine learning and data science, and what are the common mistakes that every beginner do?
How I started, well, it was a mess, to be honest. I think I had Python in 11th and 12th, and obviously none of this was there then. I mean, in the syllabus. Because, and then one day, I think I was looking at my phone's keyboard, and there's this one auto prediction which comes up. So while you're typing the word, and then at that point, I only knew dictionaries and like lists and like just basic data structures, and I'm like, fine, might as well try and make this. And it was a mess, and I had taken, I think, a few texts from books, whatever I knew from like basic Python back then. I took like a book, I manually copy pasted it, saved it to a text file and all that, and then I made a dictionary of all the words. It was like a really pathetic attempt. And then I came to college and I found out that hey, there's a proper legitimate way of doing this, and it's called machine learning. Like, okay, blew my mind. And then after that, I sort of looked at courses and spoke to a bunch of people. Um, Whatever I've done so far has been mostly towards deep learning, afterwards. Actually, machine learning and data science came about as the first thing. I did a bunch of courses, like the great Andrew Ng's courses. I think everyone's heard of them. Um, those. And after that, I gave myself projects. And that's been my journey. I learned by making stuff. So everything I showed you right now was also a project which I was doing for something else. New. Common mistakes every beginner does. That's uh, first. I think two, three things maybe. First mistake is, I think we've all made this. I make it on a daily basis. Is that I look at a lot of work that's being done, and once you start getting into these things, like say you're doing something and you find out that okay, I'm getting good at this, and then for some reason you open LinkedIn or you open Twitter and you see a bunch of people who are going crazy with it. They're making the algorithms you're using. Them one guy I know posts like three different algorithms every day. I don't know what he does or why he does it, but that's really demotivating because you feel like okay, you know what, I've gotten here, but there's no point because there's like 10 people doing 100 things different. That's one mistake I made, is to believe that. uh, and that's not cool because the fun part is you can still use everything they're making, but they can't use it in your domain. You have a set of experiences which hopefully they don't share. Even if they do, there's bound to be something different. And that's one reason why it's called data science, because you can approach it from your perspective as well. So someone who looks at the Pokemon data set might be like, huh, okay, fine, another game. But someone who's played it, I don't know, for 6, 7 years, 10 years maybe, they would look at it completely differently. Like, people might not even consider types when you look at it. That's one thing. Second mistake is that being really reliant on courses. And I feel like this is a thing because I'm seeing a lot of posts on LinkedIn with people giving courses for 10,000, 20,000 rupees. I mean, that's cool, but don't think that that's going to make you some great wizard. Uh, would be cool if it did, but no, I'm sorry that doesn't happen. Mostly these things cover the same topics. There are some people who do really cool, but still, it's just one part. And I feel like people don't seem to want to understand that you can't do much unless you're doing something on your own. Yeah, I guess these are two things.
Yeah, obviously, making projects definitely help a lot. And
A
I
lot.
believe that
True.
ignoring statistics is one of the mistakes too.
True. Very true. I mean, if you're just arbitrarily going, how, you know what, I think that this is correct, then it's probably not.
Yeah, so
True.
thank you so much for joining us today and giving us this insightful packed hour. And we are so happy to have you. We are like so happy that you could join us today and give us perspective towards data science. And I would like to thank all the audience who joined us today. And we will be back next to next weekend with another episode, as this was mind blowing, so that will be too. So do subscribe to our channel and we will keep you updated for everything.
Thank you. Thank
Thank
you
you,
for having me.
everyone.
Have a
Bye,
nice day. Yeah.
everyone.
Yeah. Bye.
Please do fill out this feedback form if you feel so. So that would be helpful for us to know what you need, what you want to know next. So thank you so much.